Section 4.3 homework, 0.31-T. Is the width of a tornado related to the amount of distance for which the tornado is on the ground? The accompanying data represent the width yards and length miles of tornadoes in a particular region for one calendar year. We're going to complete parts A through N. It says click on the icon, so we're going to click on the icon to see the data set here. It says, what is the explanatory variable? Well, the explanatory variable is the first column, which represents the width. So we're going to say that the width is the explanatory variable. Okay. Now it says, explain why this data should be analyzed as a bivariate quantitative data. So let's go ahead and discuss this. So for each tornado, the width and length are measured. The width and length variables are quantitative. Because there are two quantitative measured variables, the data can be analyzed as bivariate quantitative. So for each tornado, right, there are two quantitative variables are measured, which is what? Width and length. Okay, now we want to be able to draw a scatter diagram of the data. Okay, so let's go ahead and do that. So we're going to click on our data. We're going to open this up into StatCrunch. Okay, so now let's go ahead and create the scatter plot. So we're going to go to graph, go all the way down to scatter plot. Our explanatory variable is X, which is the width. Our response variable is Y, which is the length. Okay, and then we want to make sure that we have our horizontal lines and our vertical lines selected so that we can see this scatter plot. Now, if we take a look at the first one, we have them all here in the corner, and then we have these 4 points over here. So it could be A. Okay, if we take a look at B, okay, you can see that these points down here, and let's just open this up a little more so we can compare this a little bit better. So we'll scroll that to the left, keep this to the right. So this looks like it could possibly be this scenario. The only thing here is that you have these 3 points here, and then there's 2 points together over here, so it's not going to be B. Okay, let's take a look at C. Well, you can see that it doesn't have any of these points up here. And if you look at D, it has the straight line points, which doesn't represent that. So if you look at A, it's going to be A, checking our answer, therefore there is our result. Now, is there a relationship between width and length according to the scatter plot? So if we take a look at the scatter plot here, okay, is it a negative, is it a positive, or is it no relationship between the width and the length of the tornado? So if we look at this, it's going from left to right. It is going in a positive direction. So we're going to say that there is a positive relationship between the width and the length of the tornado. Okay, now it says determine the correlation coefficient between the width and the length. So open this back up into StatCrunch. Okay, we're going to go ahead and select Stat. Go to Summary Stats, and then we're going to select Correlation. And we're going to make sure that we select both columns, the width and the length. And then we're going to select Compute. So here is our correlation coefficient, and we need to round it to 3 decimal places. So therefore, round that to 3 decimal places gives us 0.833. And therefore, that gives us that result. Now, is there a linear relation between a tornado's width and its length on the ground according to this correlation coefficient? Well, since this is close to 1, we're going to say yes. So therefore, there is the result. Okay, now we want to be able to find the least squares regression line. So let's go ahead and open this up again in the StatCrunch. We're going to go to Stat, scroll down to where it says Regression, select Simple Linear. Okay, now again, remember that the X variable represents the explanatory variable, which is the width. The Y variable represents the response variable, which is the length. And then we're going to scroll down select compute. And now what we want to do is we want to be able to then determine this least squares regression line. Now again, as you can see here, here's our slope, and they want us to round both of those values to 3 decimal places. So if we round it to 3 decimal places, this 8 changes this 9 to a 0, and then we move that 0 to a 1. So therefore the slope's going to be 0.010. And let's take a look at the y-intercept. The y-intercept, we're going to round that to 3 decimal places, which is 0.284. Now let's go ahead and check our answer, and there is our result. Now it says to predict the length of a tornado whose width is 500 yards. Well, what we can do is we can come back in here and select options and go to edit. Okay, and what we want to do is we want to be able to predict this value. Now we can substitute this 500 into this equation, or we can let StatCrunch do it. So you see where it says prediction of y, the x value is 500. So we're going to go ahead and put in the value of 500, and let's go ahead and select compute. Now let's take a look at this display. Now if we go down to the very bottom, you're going to see that when x is 500, then the value of the y is 5.2200478. We want to round this to 1 decimal place, so therefore it's going to be 5.2. So 5.2 is our result. Check our answer, and there is our answer. Now it says, was the tornado whose width is 990 yards and length was 4.6 miles on the ground longer than would be expected? So here we're going to do the same thing. We're going to go back, we're going to select options, we're going to select edit, and this time we're going to set the value for x to now be 990 yards, because that represents the width. So let's go ahead and do that, 990 yards, and then let's select compute. And again, we want to figure out what is the predicted y value here. So scrolling down here gives us this value here. Rounding to 1 decimal place is 10.1. So the observed says that the length was 4.6 miles on the ground. Okay, so it says, was the tornado whose width is 990 yards and length was 4.6 miles on the ground longer than would be expected? Well, this now is the predicted value, and therefore that tells us that this is going to be smaller. So we're going to say no. Okay, the predicted length of the tornado with the width, that's 990 yards, rounded to 1 decimal place, is 10.1. So 4.6 miles is going to be what? Well, it's less than the 10.1, so we're going to select less, and there is our answer. Okay, now it says to interpret the slope. So let's use our display here to interpret the slope. So I'm going to go ahead and copy this information into our data sheet. So let's take a look at the slope here. So remember that the slope that we got was 0.1010. Okay. So the way we would describe this is that the slope 0.10 is the change in length for 1 yard, meaning that this is over 1 yard. Increase in the width. So it's the length over the width. Therefore, on average, so therefore every yard increase in tornado width, the length rises by, in this case, 0.10 mile. So let's go ahead and put that answer in here. So for each yard increase, okay, we're going to say that in tornado width, the tornado length increases by 0.010 on average. Okay, now in part J it says, explain why it does not make sense to interpret the intercept. Okay, so let's go ahead and discuss this. All right, so what's going to happen here is that the intercept of a line is found by setting x equal to 0 and then solving for y hat. So let's go ahead and then copy down that equation that we got, okay, which is the following. So there is our equation. Okay, using this equation, we're going to let x equal 0. So that means we would have y hat, which is equal to 0.010 times 0 plus 0.284. So therefore, y hat is then going to equal 0.284. So the intercept of this model is where the tornado width is 0. That means when the tornado model is 0, then the y value is 0.284. So to answer our question, we would say that the width of the tornado cannot be 0 yards. Next question. What proportion of the variability in the tornado length is explained by the width of the tornado? So this answer is going to be on our display looking for the coefficient of determination. So let's scroll back up here and remember that the coefficient of determination is r squared, which is right here. Okay, and the question is asking us to round it to 1 decimal place. So let's go ahead and write down the number of 0.6933. We're going to multiply this by 100% to convert this to a percent, moving this decimal place over twice, which becomes 69.33%. Rounding it to 1 decimal place is 69.3%. So therefore, we're going to say that the proportion of the variability in tornado length is explained by the width of the tornado by using the value of 69.3%. Okay, now it says plot the residuals against the width. And does the residual plot suggest the two variables are linear related? So let's go ahead and open this up into StatCrunch. Okay, and we're going to go ahead and go to Stat, Regression, Simple Linear. We have our x variable, which is the width. The y variable is the length. And then we're going to scroll down here, and then we're going to select the option that says residuals versus x values. And then we're going to make sure that we have the horizontal and vertical lines. We're going to select compute, and then we're going to move to the right to see the residual plot. Okay, so keep in mind here, here's our width, and the residuals is the vertical axis. If we take a look at A, it doesn't match. If we take a look at B, it looks like it's a possible match. Okay, if we take a look at C, we can see that there's points up here, and that doesn't exist here. And it looks like it could possibly be D. So it could be possibly either B or D. Now, if we look at B, there's 2 points that are listed here. D doesn't have those 2 points. So it looks like it's going to be selection B. So let's check our answer, and there is our result. Now we need to determine if the residual plot suggests that the two variables are likely linear related or not linear related. So it's got to not show a discernible pattern. And so therefore it does not, so we can say that they are linear related. Next, we want to be able to draw a box plot of the residuals, and are there any outliers? So in order to draw the box plot of the residuals, what we're going to have to do is we need to create another column here so that it contains the residuals. So if we go to the last box that we have, which is number 4, we're going to go to Options, select Edit, and then all we need to do is scroll down here and make sure that the residuals are going to be saved. And now we're going to select Compute, and then you will notice that it created now a column that represents the residuals. Now we need to create a box plot of the residuals. So in order to do that, we're going to go to Graph, select Box Plot, we're going to select Residuals. And then what we're going to do is make sure that there's fences that identify outliers. And then we're going to draw the boxes horizontally. So here we go. There is our box plot. So now we're going to see that it doesn't match A because there are outliers in this box plot. There's a couple over here. There's none in part C, and it looks like it represents D. So our choice for our box plot is going to be D. Okay, now it needs to tell us, okay, does there exist? So does our outliers exist? Well, yes, because in part D we see that there are outliers. So we're going to say that there exists at least one outlier. Okay, now it says that a major tornado was 4,582 yards wide that had a length of 16.2 miles. Is this an influential tornado? And then explain. We're going to select the correct choice below, and if necessary, we'll fill in any answer boxes to complete your choice. And so what we're going to do is we're going to have to add this ordered pair to our data and compare it to our previous data. So let's go ahead and take a look here. So here we have our equation from the first one. So this is our equation for the first step in our problem. Now we need to look at the next one and compare the slopes and the y-intercept. So let's go ahead and do that. So we're going to come back in here to StatCrunch, okay, and let's have the data open. And then what we're going to do is we're going to add another point to this where the width, okay, down here below is 4,582 and the length is 16.2. Okay, so what we want to do is we want to find out what is the equation for that. So we're going to go to Stat, Regression, Simple Linear. Again, the x variable is the width, the y variable is the length, and all we need to do is figure out the equation for this. So let me go ahead and copy this data down. Okay. And then we're going to compare. So we're going to have our equation. So we have y hat. Now the slope rounded to 3 decimal places is going to be 0.006x. And then plus, what is the y-intercept? Well, the y-intercept rounded to 3 decimal places is going to be 1.398. And so let's compare. So before we added the point, the slope was 0.010, and then it decreased to 0.006, and then the y-intercept from the first equation was at 0.284, and it increased to 1.398. So there is a significant change in those equations. So to answer our question, we're going to say yes. With the 0.4582, 16.2 included in the regression, the slope changes to 0.006 and the y-intercept changes to 1.398. And that concludes this question.